This is the Amp Hour Podcast. Released March 1st, 2020. Episode 482, sponsored by Screaming Circuits. Shine a light.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
We're back.
Hey, what's up, man?
What's up? Usual stuff.
You're going canyoning tonight. That's different.
I am. I'm going night canyoning. Thanks for sharing that on an electronics podcast. It's totally on topic.
Well, there will be LED lighting, I'm sure.
There will be.
And also, no, actually, we did talk about this a couple weeks ago where I said, you go canyoning still. And you're like, yeah, sometimes. And I was like, when's the last time you went? You said like last year. And now you're going. So
True. Well, I mean, I've got a wife and kids, It's
yeah, of course.
Speaking of LED lighting and stuff, I did get myself, product review time, I did get myself a new headlamp.
Yeah.
For canyoning tonight. Yeah. And it's the Black Diamond Spot. And geez, I'm impressed.
Yeah. How big is it?
It's like, how big is it?
Yeah. That's usually the impressive thing about, like, what is there to a headlamp? It's like, there's like size and weight and...
It's one of the single headband ones. So it's not one of the ones that goes over the top and has the battery pack at the back. Usually your larger, more powerful ones for like, caving and real...
Yeah, like a true torch, right?
Like, yeah. Like it's a massive, like, indoor lamp kind of, thing that lights up a whole space. So you'd need that for, say, caving or something like that. But for stuff I do, no, just your, either canyoning, climbing, bushwalking, you just need your single headband, which just goes around your head and not over the top. And the batteries are on the front, inside the enclosure.
Yeah, so it's like a rechargeable and just in there.
Yep.
Yeah.
And they run on 3 AAA batteries. You can either use, so they've designed it properly that you can either use lithium, you can use alkaline, or you can use nickel metal hydride rechargeables. So, it's super flexible like that. A lot of people forget that when you're actually designing a product, does it support the high voltage lithiums, for example? Because they are higher voltage than your regular alkalines. They can be up to 1.8 volts a cell.
Oh, really? Okay, so that could really mess some stuff up, huh?
That could ruin your day, especially if you've got like some sort of, over voltage diode clamping protection or something on your rail, on your voltage rail. You install the lithiums and boom,
Yeah, I didn't realize they went that high.
Oh, yes, they do. That's open circuit voltage. Yep, that's
right.
Brand new, out of the pack kind of thing. They will drain relatively, like the voltage will drop relatively quickly, but still, your device has to handle that, and that is a not uncommon problem in the industry. Is designing for lithium primary batteries, not lithium ion. That's a different technology.
Yeah, right.
Yes, lithium primary battery technology. Then I'm impressed by the fact that they've thought about, well, what happens if this thing's in your... I'm talking about usability design now. And you have to pull up a picture to have a look at this thing. And anyway, so what happens if it's in your pack and, it's rattling around in your pack as you're walking, you're climbing, you're scrambling over things, abseiling, doing whatever, and it accidentally turns on, for example, and then you go to use it at nighttime after your big walk, and it's like, oh, my batteries are dead because it accidentally switched on in my pack. So it's got to have like a soft lock mode, so you can put it into a soft lock mode where you have to like depress 2 buttons at the same time for like 3 seconds in order to unlock it, so that it doesn't automatically discharge the batteries. Very nice touch, in my humble opinion.
Yeah, that's great. I think that's like, usually my problem is I'm like scraping the bottom, like especially for that kind of like commodity type thing. I'm like, well, I'll just get the cheapest one with like decent reviews on Amazon.
Don't get a cheap headlamp. No, please don't.
Right.
No, you go in for a world of hurt.
Literally in Australia when you're walking around with spiders and blizzards and whatever else you guys got there.
Should I extol the other design features I thought were quite nice?
I mean, this is a lot for an LED lamp, but I mean, yeah, go for it, man.
This is why I'm thoroughly impressed by it. And the other one is that it has a sort of like a touch button on the side. It's like a touch sensor on the side that can override any of the modes that you set, because it's got like 3 different LEDs on it. It's got a red LED for night vision type thing. It's got a main LED, then a secondary LED with different angles right? So it's got all these different light modes you can do. You can just like capacitive touch sensor on the side. You just touch that and it'll instantly override any mode. So you don't have to dick around with the button. So if you're in trouble, you can just tap the side of it and it'll instantly go full power, regardless of the mode that you're in.
Right, because you don't want to be like clicking through.
No, you don't want to be, you're hanging off the side of a cliff near death and you need more light. Yeah, you don't want to be going through the different modes and stuff. So that's very nice.
Mm-hmm.
Then it's got a tiny little 3 LED bar graph on the side for the battery indicator. And you might think, oh, well, 3 is not very good. It's like, okay, full, half dead, and then dead, almost dead kind of indication. But no, it actually uses a binary sequence on there, right? So the 3 LEDs can show you the 8 different levels of the battery. It's great. And it automatically lights those up for a couple of seconds after you either turn it on or press any button. So that hardly uses any power at all to, turn on a couple of really low power LEDs on the side for a few seconds. And so it always gives you a battery indication without draining too much power. I think that's terrific.
That's not bad.
Yeah, fantastic design mode. And then the only thing I don't like about it though, downsides, okay, is they claim it's waterproof. I actually love this part. It's kind of like it's IP68 waterproof, right? So which means it can survive immersion in one meter of water for like an hour or something like that. Yeah. But there's a little asterisk next to that requirement which says, oh, the battery compartment isn't. So the electronics will be fine, but water can get in. There's no battery seal. There's no seal around the battery compartment. So I think that's kind of fun, but it'll still work if water's in your battery
replaceable batteries.
Yeah,
for that reason.
Exactly. So anyway, I think there you go. That's product of the week. The Black Diamond Spot 325. It's the new model for those playing along at home. And there you go. Where did that come from?
Well, you're going canyoning, and you didn't want to talk. You didn't want to talk about it, but then you did want to talk about a headlamp. So,
and then you brought up LED lighting. So, there you go. Anyway, very impressed. And then the different beam patterns. I love that. So you want the Spot for. Oh, you're not really getting excited, are you? No.
I mean, that's more on like the user side of things, and like I don't really go outside, Dave. So there's
right. Yeah, there's that.
Yeah.
Anyway, I like little things when you're designing products like that can make a heck of a difference. Just really small stuff,
I think that's a good point too. Like the electronics internally, like probably aren't all that complicated, and yet it is that like what makes a product is that other stuff like you're talking about. And
it's the other stuff. It's the user interface design, the experience. It's the whole Apple thing, that's what Jobs was into. Oh, it's all about the experience and all that sort of stuff, Yeah, anyone can actually design a phone, but, to make it polished and, well, you could argue that until the cows come home. But anyway, that was that was the whole point, yeah. Small things in the user experience matter. That's why I like this thing, so.
Yeah, well, and, you got to pay premiums for that kind of thing usually too, so.
Yeah, it's a bit more expensive than your cheapies, but not by a huge margin. It's not Apple prices.
Percentage-wise.
Oh, of course. Yep. Oh, all those things add up on your BOM cost.
Yeah.
That's for sure, So, yeah. Anyway, I would love to do a teardown, but sorry, I think it's like potted or something.
Mm-hmm.
Pain in the ass. Anyway, speaking of Apple,
I saw a report today that, there's obviously a lot of COVID-19 or coronavirus, a lot of people talking about that stuff.
Oh, yeah, coronavirus. It's got some other official name now. Sorry. It's like the COVID-19 is the...
I think it's like the CDC name or something like that, maybe.
Yeah, something like that. I don't know. Whatever. Yeah. Anyway, coronavirus. Yep.
But, Tim Cook was calling that it's it is on the other side. It's hard to tell, like when it's someone like at his level who's like not just saying it for the investors versus actual like the reality of the situation. But he did say that things have been getting better on their supply side. It's interesting. I don't know, but if you've been ordering stuff from China, but I finally jumped back in. I was like, oh well, the PCBs are fine, and
Well, they are back. Depends on who the manufacturer is, though.
That's right.
Okay. JLC is back and delivering again. That's all on the forum. There's a huge forum thread of how this is impacting manufacturing and stuff like that. And everyone's keeping tabs. Oh, yeah, I use PCBWay. I use JLC, and some are back, some aren't. Oh, I can't get manufacturing. They're telling me 8 weeks.
I got a little bit of a bait and switch. I had a 4 to 5 day, and then I was like looking at it again today. I was like, oh, that went to 10 days. Like, okay. Well,
Yeah.
that's.
So
I mean,
what do you,
yeah. I mean, you know,
they're still doing really good
yeah.
to,
I mean,
you know,
they're open,
get
so
these
that's
out.
good. But
They are, but I've heard a lot of the support people are working from home. Like, you know, the people who like check your files and
yeah,
stuff like that before when you upload them, for example, you know, they do like the QC check to make sure there's no errors in your Gerbers or whatever. And
hmm
yeah, a lot of those people are working from home.
hmm
So yeah, they're not actually in the factory. It's only the essential factory people that are in there.
yeah, yeah.
Mm. So yeah, but they're doing like fantastically to try and keep this on track. I mean, South Korea's being hit huge now, and
Yeah.
they're like so many companies over there are now shutting down and quarantine and cities shut, and it's just wow, they're really in full panic mode in South Korea. So yeah. And several of my YouTubers who I watch, they're like, you know, bunkered down,
hmm
for example. And yeah,
Yeah. Yeah, there was a good episode of the Macrofab Engineering Podcast. The founder and former CEO, now COO, Chris Church was on there talking about kind of how this stuff affects supply chain as well. I'll have a link for that as well.
yep.
Yeah, it's kind of weird. I mean, like, I agree. I agree that they are coming back in force and like that.
No, they're not.
No, I mean like that people are pushing for opening back up and stuff like that. Maybe not unforced. That's probably the wrong term. But they, you know, they're making strides towards it and they're pushing to open up. But still, it's just amazing how this stuff has affected the supply chain. I haven't seen anything on like the parts side of things yet, but I'm sure that that's kind of like latent in the, you know, it's like kind of where things hit. Like, is it like a leading edge or is it like trailing edge kind of thing? And like, you know, if people aren't making parts at the,
Yep.
you know, at the capacitor factory, that's not going to hit for a couple weeks yet, but that could end up hitting later on, that kind of thing.
It'll go on for a long time. If you think this thing is getting better or over, you're kidding yourself.
Yeah.
No way. It's going to get worse. Trust me. And I'm not surprised at all of the impact of this thing. Like we had to come a gutser eventually. And you
Why is
know,
that?
and people are shocked. Well, when you have something like this that's pretty much an unknown and has a massive incubation period like this thing, it's absolutely no surprise to anyone who understands this sort of stuff that it's going to cause those huge impacts. I mean, it's just everything's centralized in China, right? All of our supply and all of our manufacturing and everything else is centralized there. And, you know, people are surprised when there's a shutdown due to a pandemic like this. I mean, come on. I'm not the least bit surprised. It had to happen eventually.
Yeah, I guess the centralization of, the centralization is maybe, but I mean, that doesn't really have to do with the like the incubation time and stuff like that. Like, I guess I agree about the centralization. Yeah, we definitely are very dependent on China. That was another thing that Chris Church brought up too, was like, you know, like a lot of people when they're, you know, when the prices are low and everything's flowing fine, it's like,
Yep.
if you come to me and you say, hey, this board's going to be 5 times more because it's, you know, made in the US or made, you know, in Germany or something like that. It's like, no, I don't want to do that. But like, that's what actually is going to support the future boards and drive the volumes that would end up lowering costs domestically anyway. So yeah,
Right.
it might be a shakeup in that way, but I don't know if it was obvious that this was going to happen. That's what I heard you say, was like that it's obvious.
Well, no, it was obvious of the effects of if something like this did happen, it's obvious what the effects would have been. That's what I'm saying.
Got it. You
And
understand the
you know, it's like
disruptions.
and you could have anything. You could have an asteroid impact in bloody China or something, right? You could have a massive countrywide power outage for weeks, right? You can like, there's all sorts of things that can, you know,
Sure.
go wrong, and a virus is just one of them. Haven't you ever watched any of the pandemic virus Hollywood movies? I mean, you know,
Well, those are usually more focused on like bleeding from various
zombies. You know, they usually
zombies and bleeding from various orifices and
yeah.
that kind of thing. So no, I don't actually watch those, Dave. I'm not that kind of
They're pretty great.
yeah.
Anyway, no, like I am not surprised of the effects of this thing. And and no, if you've been listening to anyone in the last 10 years, like Bill Gates famously said it in a documentary last year. It's on Netflix, I think. I watched a couple episodes of it. And he said on there that this, a virus is going to start and it's going to spread from the food markets in China. He almost called it like a year ago.
And what was the documentary about, though?
It was actually about viruses in some respect. I haven't actually watched that episode, but it's not like people haven't been warning that something like this could happen.
Yeah,
they have. It's just that you've never heard of it.
Well, I don't watch those kind of movies.
Right? So, it just, there's absolutely no, because we've had like the SARS before, we've had bird flu and things like that. And unfortunately, they didn't reach the sort of, panic level that we're seeing now. Shelves are, clearing in South, things like that. People are just panicking and stocking up. So huge impact on manufacturing and will continue to be so. So, but the long tail effects, we just have no clue about. Like,
right.
I don't know. 6 months down the track.
Interesting is like if things will kind of come back and, stops, fits and starts and kind of things too.
It'll be interesting to see how it changes various countries' policies. It's like, oh, yeah, we are pretty centralized to China. Maybe we should think about, onshoring a bit more. Will this result in more onshoring?
Maybe, yeah.
We've talked about that over the last, maybe 5 years. This onshoring thing is a thing.
Yeah.
Right? Companies are actually bringing back manufacturing from China and doing it locally because it's almost, the cost is almost the same and there's good benefits to doing that.
I disagree with that. Usually, at least in the States, when they say, well, hey, we're going to do onshoring or reshoring, whatever, they're like, yeah, we're bringing it back. And then they go to Mexico.
Oh, right. Okay. Right.
Yeah.
Got it. Okay.
Yeah.
Or they've gone to India or, somewhere else.
Yeah.
Right. No, that is not onshoring, right? That's not true onshoring.
That's not
there
onshoring.
Has been quite a significant amount of onshoring.
Yeah, I mean, I think there is a focus on multiple supply chains at least, but sometimes like what if there's raw materials? Like there was a thing I was reading
raw
about.
Materials is a thing. Yeah.
That's like for medicines even, like a lot of raw materials for medicines are in China.
We do make a lot of medicine here in Australia, but a lot of the raw materials, they come from China. So, yeah.
Right. Yeah, I mean, it's just everything's kind of interconnected like that, and I don't know what happens then.
I think there will be quite a significant change. This is really a boot up the pants to a lot of countries, I think.
Yeah.
So.
Yeah, and companies too, I think. I mean, well, as we record this, there's been some bad days in the market. I think there's maybe more to come. We'll see, but we don't time the stock market around here, but I think what has ended up happening is a lot of like Microsoft and Apple and big companies are like, yeah, look. We're not
this
just
is going to impact us. Yeah.
Yeah. It's impacting not just their supply like Apple, but it's also like, hey, this is a lot of our customers too. The only one I've seen that's been doing well has been Zoom, which is like the video conferencing site. They have had more subscriptions in the past like couple weeks than they had in all of last year.
They're an online service, so everyone's stuck at home, so they have to find an online service to do their to continue
video
their work.
Yeah,
exactly. Right. Okay.
Yeah. Yeah, and they like in the past couple weeks they've had as much business in the whole previous year or something like that.
Oh, so, wow!
Yeah. So I mean, but that's kind of just how it goes,
winners.
Yep.
Yeah,
right.
That's right.
Yeah,
I'm sure the mask manufacturers are doing fantastically.
Oh, yeah. The people who
if you're in that business,
Amazon. Yeah.
Right. Yeah. Because I watched prices double and triple and go up 10 times. Pay $100 for one mask.
Yeah.
Oh wow.
Yeah.
Unbelievable. So anyway, it's a huge deal. So I'm sure we'll be talking about that ad nauseum for the next 6 months.
Yeah.
Like if you think there still won't be impacts in 6 months' time, I think you're kidding yourself. I think there's a big long tail to this.
Yeah, we'll have to have like a check-in segment or something like that. I don't know what it'll play out like, but it'll be interesting.
All right, let's move on from the coronavirus and its huge impacts. Can we do an anti-chip of the week? Anti-chip of the week.
Like do not use this chip.
Do not use this chip. I just threw this on Chris. He seems like he's like a deer in headlights. He's going, what?
Well, what is the chip? I'm worried. I'm already using this chip, Dave. I'm like, oh.
I just released this video like moments before we went live here.
This is the thing you found in the trash.
The dumpster, the NAS. I found a Synology NAS, a 4-bay Synology NAS, brand new in the dumpster. Turns out it didn't work. The reason it didn't work is because of this is not new news, by the way, is because it uses an Intel C2000 Atom processor. And that processor famously has it's not a bug, but it's a silicon degradation defect.
It's not a bug.
It's not a bug. Well, you could maybe say it's a fault in the masking or something like that, but it's not a bug because the chip, when it was sent from the factory, it did work, right?
Oh, interesting.
It did work, but then it degrades very quickly.
Part of, like,
so it's a silicon degradation.
Or like what is the degradation happening from?
It's actually an output. What's happening is there's an output driver clock, right? So it's one of the it's called the LPC clock for those LPC clock 0 for those playing along at home. That pin is a 25 megahertz clock output that's designed to drive external boot flash ROMs and external bus type stuff. And that output driver, it'd just be like a standard CMOS totem pole output driver, right? It's got a MOSFET on top, MOSFET on the bottom, drives the output high and low, right? Very incredibly simple, basic stuff. Been doing this for 50 years, right? And, haven't been doing CMOS for 50 years, but you know what I mean. And it looks like potentially from my testing, like the upper transistor might have failed, so it can't pull up. Right, so it actually the chip actually degrades over time. That particular transistor actually degrades in some aspect, and it can't pull high, and that's not good because your totem pole output, you rely on it pulling high. You don't have a pull-up resistor. So you might think, well, what's the fix? The fix is to actually add a pull-up resistor, to add a low-value pull-up resistor. Because it's 25 megahertz, which is really fast, and there's lots of capacitance on the bus, you have to add a low value, 100 ohm, 100 ohm pull-up. So I was driving like 33 milliamps or whatever, But it kind of works, and the waveform's horrible. I show it in the video. The waveform has this weird little step in it in the undetermined region, and you don't want that. For those who don't know, when you're designing digital stuff, you want to transition through, you want to transition as fast as humanly possible, right? So there will be maximum specs, for example. There will be maximum slew rate specs for inputs on chips, CMOS digital inputs. And if you exceed, like for regular 7.4 HC or something, it's like 500 nanoseconds, I think. So if you exceed, so if the slew rate of your input signal is too slow, i.e. it's slower than 500 nanoseconds or whatever your spec is for that, then your chip is not guaranteed to perform. It can go into a metastable state. If it's a clock input, the clock will just go and start metastably oscillating and doing all sorts of things. And it's not good. So, and the clock in this thing looks horrible. So it's not, especially when it's rising, it doesn't transition straight up. It's sort of like goes up and then goes up to about a volt and then just stays there for 10 nanoseconds or something and then goes up again. It's got this little steppy porch thing, and it just looks, but it works. I did the mod. I added the pull-up resistor to this NAS box, this clock line, and it worked. And apparently that was the factory fix.
And that's why you think it was in the trash too?
I believe that's why it was in the trash, because it was practically brand new. Like this is like a $700-800 NAS.
And that's network attached storage for people who don't know.
Network attached storage, a RAID type.
Right.
Yeah, multiple drive bay. Yeah, network storage thing. And so it's very expensive, and it was tossed because it famously, nothing to do with Synology, it wasn't their fault. Tons of manufacturers that use this Intel C2000 processor were impacted by this. And they all have to either scrap their products or figure out a workaround like this, which was the pull-up resistor.
Would you actually use it? You wouldn't actually use this as a drive thing, though. Would you trust it or no?
Technically, you can trust it because all it's doing is doing the boot thing, right? All this clock does is loads the boot flash ROM when you power it up. So as soon as you've done that, so in theory, like it's got nothing to do with saving the data on the hard drive. So actually saving the data, like actually having secure data on there, it doesn't impact that at all. So from that aspect, it's completely safe to use. But the fact is, no, it could actually degrade even further. and somehow, and it just won't boot anymore. But then you could still recover the data from your hard drives. You could put those drives in another thing and actually recover the data.
So the C2000, all these people have to either put a fix in. Like, this seems like a really big deal. Like, what? I didn't actually hear anything about it.
This was in February 2017. It was huge.
Okay.
I missed as well because I don't, I'm not using Intel C2000s. But yeah, no, this is enormous. Impacted, probably hundreds of manufacturers, huge names.
Yeah, that's crazy.
Cisco and all sorts of companies, and they all had to come out with all these responses and fixes and all sorts of things.
And they're like quasi-embedded. I never really got, like, when I think of Atom, I always think of like they were in like low-cost laptops. That's all I really remember. But it was a pretty broad line, wasn't it?
Oh yeah, it was huge. It was used in tons of embedded things like these NAS drives and network servers, and all sorts of stuff we just don't use daily.
Yeah.
So yeah, huge deal. And it wasn't guaranteed. Depends on the design of your product. Wasn't guaranteed this would cause a problem if you didn't use that pin to power like a boot ROM. You could do boot ROMs in other ways, right? But that was just like one of the easiest methods to do your boot ROM. And of course, a boot ROM is pretty important when you're powering up your product,
Right.
So, yeah,
I've heard this. Yeah.
And yeah, a huge problem. So yeah, that was an oopsie. I don't know what impact that had on Intel, like on their share price or their reputation or whatever. But yeah, that's pretty bad. And it's not a bug. Like, you get bugs all the time. You go to the errata for the C2000. It's just like any micro. Go and look them up. Look it up, all the issues and bugs that will be in the chip, and they'll either go, oh, it's fixed in this step in of the process. So the step in is the version of the silicon. But a lot of them, a ton of them, especially in the C2000, it's go, there's no fix, no fix, no fix. Sorry, no fix, no fix. Yeah. We advertise this feature, but sorry, just doesn't work. So, tough tits.
Yeah. I was surprised by that with, I think it was, so I was on Embedded a couple weeks ago, and we were talking about some of this stuff. And I think it was Chris White was saying like, well, and like sometimes it's just like the manual's wrong or this thing doesn't work. I'm like, that can't be right. And then it happened to me where I was like, yeah, this is just like an undocumented, like, it just happens, like, and
I know you do not believe it until it happens.
It's very jarring, it's like you just expect that this is like a perfect thing that you're using, maybe quirky or whatever, but it's like you don't expect it to be like just not fixable, not working, like that's.
Yep. And sometimes they'll come up with fix arounds. I can remember, various PIC processors I'm using over the years, and it's like, oh yeah, there's this bug in the, this timer or whatever. So we came up with a software fix. So you have to do these instructions, write these instructions first, and that kind of sort of fixes it. And if you don't write those first, and we won't tell you why, but if you write those first, then it'll suddenly magically work,
Yeah.
And I've had entire serial ports not working. I've had pins swapped on the chip. It's like, I couldn't figure out why it's just, yeah.
Maybe it was you saying this. Maybe it wasn't Chris White. Maybe it was you saying this, or it's just someone was saying it to me recently.
I've mentioned this before over the years.
Yeah, maybe that's what it was.
Somewhere.
Okay.
Yeah.
For me, it was like I was using a timer. I had it hooked into like a low frequency oscillator, and like there was like a divide by 8. Like I wanted a really, really slow clock.
Right.
And so I'm like doing all these tests, and I'm like, this isn't working. The clock, I expect it to be 10 seconds long or something like that before it ticks over, 10 seconds long. And I'm just like, it's never firing. It's never happening. What's going on here? And it turns out just like the divide by 8 just doesn't work. It just
doesn't work. Which chip was this, name and shame?
Oh, this is on the EFM8, which I like otherwise. I talked about it on that episode, but like otherwise I like it.
This is the Gecko, is it? The EFM8
No,
Gecko?
the smaller one. The 8, it's Gecko is the EFM32.
Okay, right.
The 8, I'm not sure if it has like a brand like that, but maybe. But like I said, I like the chip otherwise, but it was just like, ooh, I don't know,
And it's not like, and yeah, it happens to every manufacturer. You're going, PIC's famous for it, or these EFMs are famous for it, or Atmels are famous for it, and then you move to some other chip. No, it's there's no point trying to avoid it. It's going to happen.
Well, the thing to think about is like these are even small systems like an EFM8 has a ton of transistors and a ton of circuits going in there, and then they're on to the next thing.
Complex.
What people will hear is I'm going to tease next week. I interview a chip designer next week, and hearing him talk about like the amount of designs that they do where he works.
Yep.
Oh my God. Like it's just like Like, like the speed that they work at, like, I'm sure that they're very talented and they get a lot of stuff right, but it's just like, it's got to be physically impossible to get everything right.
Yeah, no, and they have to reuse modules from previous chips. Asking what percentage of stuff they reuse from the previous design, it's probably 99%.
I did ask that actually, and it was very surprisingly not the case.
Really? Okay.
Yeah, this is a real weird one. Well, I'll again tease something else for this episode. I told Dave, I sent Dave a message after I finished interviewing this person, and I was so out of my element. I have never felt so confused and yet wanted to be so confused. So really exciting episode coming out next week.
but that is not like micros and stuff. This is like ultra high frequency.
Yeah.
Extreme high frequency, like hundreds of
500 gigahertz. Yeah. 500 gigahertz. It's just like, holy shit.
So to him, like like several gigs is DC, right?
Yeah, that's what he said. He said 3 gigahertz is low frequency.
Yeah,
I'm like, what?
Low frequency stuff.
What?
Yeah.
What?
Exactly.
But then they have micros on board and a bunch of other stuff too. So like, yeah that's.
So this is even a level above Sharia, who works on like 80 gig or something, doesn't he?
Yeah, I think they're kind of. I would put them in the same realm. I think
they're probably in the same category.
I think. I would love to watch those two. So this is Adrian, who will be on the show next week. I would love to watch Shahryar and Adrian talk to one another. maybe we can hook that up. We'll just put them in a room and film them and see what happens.
Lock the door and
yeah. You just slip some food under the door and like
that's great. Yeah. And if you wonder why there's so many like errors in data sheets and things like that, is because when they come out with a new micro, somebody doesn't just sit down and write the data sheet. All they do is copy the data sheet from the previous nearest chip and then go through and modify it and make changes, right? And you're just going to miss stuff. So there'll be stuff in there that's just completely and utterly wrong because they churn out like, hundreds of chips a year.
Well, I'm sure there's a lot of people checking it, but like, there's small things that sneak through, that's
guaranteed things are going to sneak through. That's why, always download, make sure you have the latest data sheet. Like that it can change
great
weekly.
Advice. That is great advice. It's easier if you're on old silicon, right? I think that a lot of it's been sussed out.
Old mature silicon, it's like a lot of people love using the 8051, it's just so, ironed out.
Well, that's what the chip I'm talking about is. So,
right.
We're excited to continue to bring you sponsors that are interested in educating our audience. Today, we're going to hear again from Dwayne from Screaming Circuits, who you may remember talked about a through-hole pick-and-place machine last time. Today, he's going to talk about the setup of a low-volume manufacturing solution so that you can get prototype boards made quickly through Screaming Circuits.
We can manufacture and machine manufacture from cut tapes. We've created a system of plates that allow us to set the cut tapes down in precision. So, say you order from DigiKey and you need 20 parts and they give you a strip of 5. We can put that on a fixture that will then be precision enough for our machines to pick and place. It really doesn't slow anything down because when we're putting the components on the plates there, we also have our machine programmers going through and double checking the designs, checking footprints, checking polarities, and getting our machines programmed up. So there really isn't any delay. It's happening in parallel with other services. And then when it comes time to put the solder paste on the PC board, we save a little more time there also because we don't have to order a stencil in most cases. We have these big PasteJet printers. They're kind of like inkjet printers, except putting down solder paste.
I've actually run a prototype board through Screaming Circuits before, and it had some really tiny pitch parts. But more broadly, I'm curious about what happens when you want a fast circuit board, but it also has these crazy small pitch parts that are available these days?
Well, the machines that we have now can go down to a 0.4 millimeter pitch. And then below that, today, we need to use a stencil. We won't very shortly. Probably by the time this goes live, we will have, we're buying a set of new machines that can go down to 0.24 millimeter pitch BGAs. And that allows us to use those PasteJets for any component we get in here. And that's one of the other interesting things about Screaming Circuits is that we have so many different jobs so frequently from so many different industries that we tend to see the new components before most other companies do.
So of course I had to ask, what's coming down the pipe? What do we expect to see if we're working on the leading edge of packaging for electronics?
Well, certainly the super small pitch BGAs, they just keep getting smaller and smaller, and larger in terms of number of balls. The LGA or land grid array, that's basically like a BGA except without the balls on it. Those are becoming pretty common in small components themselves. These kind of tiny dimensions, things that a few years ago weren't precision, precision wasn't required. Now it absolutely is.
Ultimately, this is why I chose to go to Screaming Circuits instead of trying to solder it myself. The pitch on the component I was using was just too small. So if you have a build coming up with a bunch of small components on it, or you want your designs fast, check out screamingcircuits.com/theamphour, and you can learn more about getting your boards made. Now we're back to the show. So this whole space, I wanted to bring up a chip, maybe a chip of the week this week. I don't know. But this is a new one, the +1. Did you see this link on our subreddit?
I have the link, but I have not.
So basically, this is kind of filling that space of like the BeagleBone Black and the Raspberry Pi and custom solutions that are out there. And basically, I was really surprised that this is so it's called the +1. It's from a group called Tibbo, Tibbo. And it's got a whole bunch of it's a quad A7 processor.
Yep.
It's also got 8051 to do low level stuff.
It's got an 8051 on the outside. And what does the 8051 do? Just supervisory stuff?
I think that's for low level, high speed stuff. So that's kind of like more like a BeagleBone, where a BeagleBone has internal microcontrollers that interact. They have shared memory with the actual A53, whatever. I forget what's in the BeagleBone.
Okay, I didn't know that. Okay.
Yeah. So if people go back and listen to the episode with Jason Kreidner and Robert, I can't remember Robert's last name, Robert Nelson from DigiKey, that was like an amazing chat with them, because they I didn't realize that all that stuff was how it was working. I had no idea when we were going to that episode. And it's great though, because like that is like it's kind of a good mix of high level. You want to like talk to a network. You want to have actual Linux running on there. You want to run, Node.js, or you want to, run Python or something. And then it can talk down to these modules that are watching a process and just acting based on input, right? So it's watching when a bit comes in high, it goes and does a spy command or something like that. Fine, good, whatever, right? And then it dumps it into memory, and then you can read that memory later. I'm working on a project right now that's like this, where I actually have discrete boards that are kind of all talking to one another, because I wanted to do something like this. And I wanted to actually have some supply chain stability of like, I'd rather make a system that has, small microcontrollers that talk over serial in this case, up to a larger Linux system. But like this is now shrinking all this stuff down. And I think this is going to be a more and more common thing, is you want to have a system that has memory internal, has all the drivers internal. So this thing has processing. So it has integrated memory. It has integrated power. So you only have to give it 3
integrated 128 meg or 512 meg DDR3 integrated.
Right.
Yep. It's 5 volt tolerant. It's 5 volt tolerant for you 5 volt fanboys.
Right. Exactly. And exactly. So like this, and so like they're kind of targeting the industrial space. It's, it's actually -4 to 80, -4 to 85 C for temperature rating and stuff like that.
Yep. One of the most interesting things is that they know one of the pain points to acceptance of these new devices is, well, will they be around in a couple of years? If I design this into my product,
yes,
will I still be able to get it in 5 years' time? That's why one of their key highlights is a 10-year supply guarantee.
Right.
It's right there, right in the main features, 10-year supply guarantee.
To me, that's always like, hey, we are targeting industrial, right? Or we're targeting automotive. Probably industrial, though, because I don't think automotive would use something like this. But
yeah.
And it's got like a huge... So I was a little surprised it's actually a quad flat pack, which is kind of surprising.
It's a quad flat pack. Woo!
You prefer that, actually?
BGA rubbish, of course.
Yeah. Okay.
Who wouldn't prefer a quad flat pack over a bloody BGA?
You could have more bridging, I suppose. I don't know. I mean, but
Come
you'd see it then.
really?
So then that's nice. I mean, for rework, totally, it's better, like that kind of thing. It's pretty fine pitch, though, isn't it?
I don't know about the pitch. Yeah, it's probably like 0.5 millimeter or something like that, perhaps. But still,
yeah,
come on, that's a huge plus. I mean, that's absolutely amazing.
Yeah, and then the other interesting thing is something I really like about the NRF 52 series. The 840, the 52 840. It's got like completely every pin, or almost every pin, is reconfigurable, and they're kind of promoting that too. They have a different chipset in here that does like the actual routing. So every pin is kind of wired to this. What do they call it? The flexible peripheral multiplexing. But boy, that has saved my bacon a couple times, Dave.
Oh yeah, it's very nice. I know. Yep.
Yeah. And at least on the NRF,
and it makes your board layouts easier too, because
totally.
you can just like swap it later. You know, you got
Yep.
flexibility in your pin swapping. Does KiCad have that? Does KiCad have pin swapping?
It does not yet. That's in version 6. Yeah.
Okay. All right.
Yeah.
And version 6 is what they're working on at the moment, is it?
That's the one. Yeah, exactly. Yep.
Right. Okay.
Yeah,
Gotcha.
that's one thing they've been pushing for a while. And then the other one that's they're working on the DRC engine right now. And I ran into that with some of the board. We can talk about that in a little bit here after this chip, but I ran into that with some of the boards that I was working on, and I have some interesting stuff from that. But let's finish up this thing. I mean, so it's got Yocto, which is what we talked to. That's not what we talked to Jason. That's what used to run on the BeagleBone Black. Now BeagleBone Black runs Debian. So Yocto is like a custom build, and so you can kind of build it up based on what's in your system. I'm guessing that's why they use it here. I have never used it other than what's been like, I think, on my original BeagleBone, maybe not the BeagleBone Black, but I assume it works fine. Yeah, I mean, at the end of the day, like, I'm working with software people. I'm making hardware for software people, and I need to be able to give them, a lot of them are like, hey, look, I just need to be able to run Python. I need to be able to run JavaScript. I don't want to run embedded stuff. And it's like, something like this is actually really, really interesting. So I'm going to be looking into this more.
No, I think this is fantastic. Wow, I'm just looking at this and I thought they've hit a home run here.
Yeah.
It's got built-in Ethernet Max. It's got dual Ethernet Max built in. It's got 4 console UART plus 1 console UART. It's got 4 UARTs plus 1 console UART.
Yep.
Incredible.
Yeah. So on our subreddit, someone wrote in too that they Swedish Hat took a trip to Taiwan last year and met the Tibo guys. They're a cool group. It is expensive, so not in this comment, but it is $20 for a single unit. But you can get a single unit, which is nice.
Can you buy it on DigiKey?
I don't think so. I don't know about that, but I think the contrasting thing is like, so
Firmax Australia. My God, I've never heard of Firmax. Firmax is the Australian distributor. What?
Yeah.
Yeah, it's got all these oddball distributors. Oh my goodness.
Yeah. So I think you're comparing it to like a Raspberry Pi though, right? So that's kind of like what it is. It's like, this is like a Raspberry. If you stuck this thing onto a board going out to a 40-pin header, this is effectively a Raspberry Pi.
Has anyone done boards with this yet?
There are a couple out there. On Twitter, I saw one. I'll try and link it in. But the idea is, like, if you want to go and take a Broadcom chip and put it on your product, you can't. You have to go and get, a Pi Zero or a variant or whatever. You literally can't get the chip that's there. This is something that is like possible to take there. Now, to be fair, the BeagleBone stuff, that's what the Octavo project is doing. So the Pocket Beagle, which is like a SOM SIP, I forget what the thing is, but basically it's the same kind of thing where it's all packaged into a Polymide BGA, wide pitch BGA, like a 0.8 millimeter pitch BGA package. Yeah. That's the same kind of idea. And I think that now we have two. I think that's actually pretty compelling, especially if you're trying to put Linux down onto a system and you don't want to put all your memory down yourself. You don't want to do your controlled impedance stuff. Now it's like, it's all there. It's all good to go. You're going to pay through the nose for it. I think the Octavo SIP is like, I think you can get a Pocket Beagle for $25, and I think the Octavo chip is $30. So,
right.
Yeah, that, but this is $20 as well. So like, but if you want Linux on a board with a single thing soldered down, that's pretty sweet, especially in the industrial space. It's like, yeah, whatever,
Wow. I'm thoroughly impressed by this. I might look into this potentially for my computing cluster project, which is always on the backbone,
Sure. Yeah.
So, yep. That's definitely chip of the week. That is. I'm thoroughly impressed by that. Wow.
Yeah. It was on Twitter, and I've forgotten who it was now. I'm sorry. Arturo. It was Arturo who then linked it from someone else. So.
Okay. Yes, and they sell programmable modules like DIP modules that you can just plug in as well. They're 27 Yankee bucks for the module that you can just plug in.
Yeah.
And yeah,
it's interesting. This company is kind of interesting too. It feels like they're kind of in this space in general. So it seems like they might be a cool one to poke around on their site otherwise. So I'll be doing that, and I'm sure Dave is too. So.
Wow. Yeah, no, I'm actually really rather excited by this.
Yeah.
Wow. Yeah, awesome.
So on the circuit board, I'm actually curious for you because you're a longtime Altium user, and I think KiCad is moving towards copying some more of the Altium style DRC stuff. But what I ran into this week is like I was panelizing boards and I'm doing V cuts, and like I had traces near the edge of the board, and what I realized is the traces, you know, the DRC is listed in terms of like the clearance around the trace. So in this case, it was like a 5 millimeter clearance, but then it got near the edge of the board, and it's like, all right, well, you can go up to 5 millimeters away from the edge of the board, and that's not good because a lot of
Well, you would normally set a zone for that. You'd set like a board clearance zone.
So you would have to do that manually. Yeah, so I could do that too.
Oh, you would do that manually. Like, I can't speak for the latest version of Altium because I don't use the absolute bleeding edge of Altium. I don't keep up to date. I'm not doing that advanced stuff anymore. So, yeah. So it may have things like that, but you've always been able to do this. Yes, you do it manually. You would have a board level DRC zone, right? So that if it goes outside that, you'll get flagged. So okay, your V. So you just need to like manually sort of know that your V cut is going to encroach on your board by half a millimeter or a millimeter, and you need to keep everything within that. And then you allow for some tolerance as well. So you might add on another millimeter. Just as a safety.
Yeah, and so what I ended up doing is I had flexibility on like the size of the board, so I just bumped it out. I bumped out the V cut like a half millimeter to the right, and that gave me enough clearance, and I was fine. But yeah, that was a little frustrating. And then because like that wasn't really published.
Oh, because you had already routed your board, so you didn't want to.
This is at the end. And it was tight. This is one of the tighter boards that I've done recently.
Yeah, no, you got to think about this stuff before you start your layout.
Yeah,
these things should be in place. Like seriously, PCB design is 90% placement and setup.
Preparation.
And this is part of your setup. Is setting up all your rules, setting up your clearances, your outlines, and all sorts of. Once you got that, then you can route.
Right, right. You can do anything you want, except you got to tell yourself what not to do.
Yeah. Yep.
It's So there's that one, and then the other one was the space and trace. So I'll just say it was JLC. It was space and trace to 3.5 millimeters, 3.5 mil.
And you're complaining that wasn't. Are you complaining that's not good enough? That's insane.
No, that's great. No, that's really great. I needed it
for standard. Geez,
Yeah. No, that's great. Fine. But the thing that was different that I got tripped up by was the trace to via. So because of the clearance around, as a standard via, not like laser cut, not anything like that, it was larger. It was based on, it was 5 mils for that. So the problem is that I can't set a clearance zone on a via. I can only do it based on the trace itself.
You can't do an individual.
So I could go in and I could click every via and say, okay, actually the clearance on this via is 5 mil, but I don't want to do that,
Oh, right. Okay. Yeah, of course.
So like the workaround that I had was upsize every via, and then because I usually only use one. I usually use the smallest one I have available to me anyways. So upsize every one so it's that larger size.
No, don't push your vias unless you absolutely have to. Don't go small. Just because the manufacturer can do 0.3 millimeter hole or whatever, and just don't.
Actually, it's 0.2 to
unless you absolutely have to.
Yeah, I know. But I actually had to. I was really really struggling on this board. It's tiny. In this case, I can't. So that's another thing I was wondering though. Is in Altium, is there a via level clearance versus just a track level clearance?
Yes, there is.
There is. Okay. So I'm kind of hoping that kind of overhaul is something that KiCad's coming out with, but I haven't actually seen that new stuff yet, but there's something coming with DRC. So, and it's going to be more Altium like, I guess.
Well, that's who they're competing against. I mean,
I think so.
You may as well not bother competing against anyone else. I mean, it's Altium and everyone else. That's they own the market.
So, yeah. I think. Well, I don't know the whole market, but I think the broad market.
But they're
the broad market.
Yeah. They are the ones to beat. Do a lot worse than copy, Altium's features. That's for sure.
Yeah, I wouldn't do all of them, but there's some cool things in there. All right, so we've got chips, we've got layout. We talked about a little bit of firmware. We talked about coronavirus. What else should we talk about, Dave?
Product of the week. I don't know. I'm just going through the Reddit list.
Well, there is another KiCad based thing. There was a really cool plugin where you can see a time lapse. So it's like kind of silly, but like it's
Oh, that's a plugin. I saw that on Twitter and I wondered how they did that. Oh,
yeah.
it's a plugin, right?
Yeah.
Okay.
Yeah.
Got it. And it just snapshots it every 10 minutes or something? Is that the
think so? I'm actually not sure.
So does a snapshot an image and then it converts it in, and then you have to manually convert the images into a video, or
it ends up as an image and then that has to get like compiled like FFmpeg or whatever. So it's not like, it's
right. It's not completely automatic, but it at least saves the images. That's a great
and it looks
feature.
cool, right? I mean, like to see how people progress. I think that's a really
and
cool...
it automatically did all the different layers, right?
Yeah,
and it automatically it didn't just screen capture. It seemed to have like the board outline, and it stayed as the outline, right?
That's right.
Which was like I wondered how they did that, like, because I've done time lapses of board layouts before, but you just see me zooming in and out and panning around it. But this actually stayed on the actual.
Yeah, so this isn't like a video capture of your screen, which is like what you're
No,
about.
it's a no, it's totally different. This is why it needs to be a plugin. It needs to plug into the software and extract that information and then essentially render the screen again in a fixed size, so that the board all just fits, and then boom, boom. Yeah, that's absolutely brilliant.
Yeah.
Love that. Wow. That's a feature that no one would have added because people want it.
That's right. Yeah,
it is something. It's like somebody. There's just one person the person who wrote it wanted this capability just for kicks, and they did it. Yeah. It's like no PCB company in the world, you don't, there's no fear of Altium copying that feature, because no professional design engineer wants, to screen, do that sort of thing. But it's cool.
On that same thread of like something that nobody would ever think you need. So there's a tool for KiCad. I know I'm very KiCad focused, so please forgive me on that. But there's a tool called Skittle, right? So it's by Dave Vandenbout, former guest of the show. And it's basically like a netlist based thing. So instead of like drawing a schematic, you can type out the netlist, right? So you say like, so you had to talk about it. Yeah, I knew you wouldn't like it. Nobody is surprised by that.
1980s.
I know, but when you think about it, like when you think about like actually scaling this stuff up, or you're doing parts that have, say you wanted to script all your checking, that your signals are all hooked together, right? So like data line 1 is from your FPGA is going to data line 1 of your DRAM or whatever it is. You can start to do scripting and interesting things like that. Well, the silly thing that happened is someone who's doing contextual electronic stuff, I show people how to make Blinky, but he took it and he basically used Skittle to make a Morse code thing. And there's a web page you can go to and have it so that it auto generates different Morse code Blinkies using 555 timers and Skittle.
Right.
And so you can basically spell out with multiple circuits using multiple 555s. And you can like basically have it say anything. And it's like really silly, but it's the idea. It's like this scalable circuit idea, which is kind of cool, right? I mean, it's kind of like that same idea of like in FPGAs, you can replicate circuits and build up, small blocks and build bigger blocks from that. But I'd never seen it like on a web front before. So I thought that was kind of cool. That's kind of like the idea of having that Skittle thing.
Nice.
So, yeah.
Is that feature of the week, plugin of the week?
Yeah, I guess so.
Script of the week.
Yeah.
I don't know. Yeah. We're almost up. Last dibs. Dregs. There's a newbie's guide to JTAG. I've done a video on JTAGs.
Oh, you have? I was going to ask you about that actually.
Yeah.
So like,
yeah. I've got a.
So what did you do?
I've
in
done
your
a video on JTAGs. Hang on. EEV long.
Dave's Googling himself.
I am Googling myself. What is JTAG and boundary scan? It's got 287,000 views, and I did it 6 years ago. Holy crap. Yeah. Okay. Yep. Yeah, no, that's very popular. I think if you just search JTAG, I might be number one. Yep. Search result number one.
The reason I was going to bring this specific one up is because like, we've had Peter Esdentempsky on the show before, and he does a Blackmagic probe, which is like a hardware, debugger, stuff like that. And there's JTAG chain tools that are doing similar things. And I guess one thing I wanted to say is because I was, even up till recently, I was very, very confused about what's happening there. But it's actually just like reading and writing registers in order to program a chip. Well, I don't know. For some reason, this was always very confusing to me. Like the idea of JTAG.
Well, it's not just for programming a chip.
Right.
You realize that.
Doing debug and...
It's for testing as well. Boundary, that's what boundary scan is.
Mm.
Boundary scan allows you to actually directly read all the I/O pins. Allows you to directly read all the pins.
So you would use that like that was like when you were doing your testing days and stuff like that, I'm sure.
When you would do automated testing and stuff like that, yeah. So that you can test the assembled board that, that pin can toggle and it's not shorted to ground, you know.
Yeah.
That kind of stuff. So
yeah, so you would like write a script that would basically go through each pin and test it to do different things, or what?
You can toggle pins, you can make them do stuff, or you can read them just to check if they're shorted or not, or if they're actually connected.
That's cool. Yeah,
things like that. Yeah, no, you can actually check the physical functionality on your board.
Yeah.
So yeah, no, it's really handy. Not everyone does that. It's like
right.
Boundary scans are a thing that you can do, but it's not hugely popular. I guess it depends on the product. But it is possible. That's all part of the JTAG interface,
Yeah.
You can make sure it's connected. If you want to make sure, if you don't have X-ray gear available and other stuff, you can make sure that your 1000-pin BGA, that every one of those pins is actually connected to the board.
That's nice, yeah.
By doing a boundary scan, make sure it's not shorted to the pins next to it.
Yeah.
For example, by actually boundary scanning this thing.
Yeah,
so
that's great.
Yeah. So just like it's not fast. So it's not like you can read out all the data from the pins in real time, and that's simply not possible.
You can't slave the whole device and like take it over from there or something.
No, it's where you can at extremely low frequency. Yes, you can actually take over the physical chip, disable all the stuff inside, and then write your own stuff to the pins. Right. So yeah, that's possible, but it's it's a serial. It's a lowish speed serial interface. It might be tens of megahertz or something, but if you've got 1000-pin BGA and you need to write one bit at a time,
right? Yeah, you're not going to control a DDR3 memory bus or something like that, right?
No, that's right. So but it's possible, and it's very cool, and it's all through the JTAG interface.
Yeah.
Because hence the name, Joint Test and Action Group.
That's right,
Joint Test and Action Group, I think. T is test.
Yeah, I knew that.
That's part of it. It's not program. It's not Joint Programming Group.
Yeah.
It's Joint Test.
JPEG.
So,
JPEG.
Yeah.
It's not JPEG.
No. What? Is there a joke in there that I?
No, that would be programming instead of test. JPEG instead of JTAG.
JPEG. I thought the JPEG might have meant something else.
No.
No. Okay. Right.
No. Yeah, I mean, so what I was getting at is like, I use JTAG mostly for programming and debugging and similar kinds of things. And, usually there is singleware debug, which is, it's usually a subset of the pins that are in JTAG as well. But I never really like understood what was going on there, I guess, and
watch my video.
I will, Dave. Maybe I should have done that 6 years ago, but I don't know.
You should have, yeah.
I think like even if I would have watched it, I didn't quite get it in the context of like doing the firmware like I've been doing lately. And that's kind of like what I'm getting at. It's like it's sending back.
Or you just didn't care until you needed it.
Yeah, I think that's probably the most accurate. Yeah, exactly.
Yeah.
It's like you don't really care about it because I got other things to worry about,
Yeah, of course.
Yeah.
No, it's right.
Yeah. But I think that there's like I don't think there's a use case where I'm going to go and like write to the registers and like handle all the stuff that does all the debugging and things like that. But I think that understanding what's going on there might, so even like selecting your JTAG speed, you might be more or less willing to slow it down because you need to get throughput, that kind of thing. So yeah, that's all.
Yeah. No, JTAG's cool.
Yeah.
What's not cool is the non-standardness of the pinouts and stuff like that. You can often be there are sort of de facto standards and things, but
like a 20-pin header versus like a something else, or
a 10-pin header versus a single inline one, or various pitches, and they all change. And yep.
So, end up buying a $60 cable from a Tag Connect. Or...
Right. Yeah.
Yeah, I've been doing that lately.
Yeah.
A lot of people say to me like, so I've been using Tag Connects lately, which is like a cabling solution that, you see at trade shows and stuff like that. And it's nice. It's small, whatever. A lot of people are like, well, make your own. Why don't you just make your own? It's like, yeah, I could do that. But the feature that I want is actually that I don't have to make one if me and Dave are working together, I don't want to buy Dave a cable. Like, I don't want to make him a cable. I don't want to be the cable maker. I want to be the person who's like, here's a part number, go buy this thing. And I don't care if it's Tag Connect or anything else. Someone wants to go make a replacement for it. Great. I would love for someone to write in the comments, here's a cheaper, better solution. Great. Awesome. Bring it on. Yep. But right now, I just use Tag Connect.
You aren't in the cable business, and you're not very protective of
that's right.
your market there. So
that's right. Yeah. Yeah. I mean, like, I wouldn't say like, well, you should just go, you could go wind your own resistor and wind your own inductors. You should go do that. It's like, yeah, I could do that. I don't want to do that 1,000 times though. Like, I don't know. This is, yeah. We might all be there soon though. If we got to make our own parts, if we can't get parts, we got to make parts, and that would be an interesting project, Dave.
That desperate.
Make our own resistors, make your own inductors, make 100 of them, all the RF people are like, we do that. Whippersnapper.
I grind my own crystals.
That's right. Yeah, exactly. Yeah. Isn't there someone who does that? Like they make everything. There's like a YouTube channel that does that where they like make everything from scratch. They had to like make a toaster. No. I thought there was.
Really?
Like, yeah, I'll link it in if I could find it. I thought there was one where they had like source and make a toaster, and it was like a ton of work, even for a pretty simple thing like a toaster.
Yeah, a toaster's pretty simple.
Right.
Wow. Terrific. All right. Well, that's our amp hour. Our capacities
fully and truly up. That's what he usually says is there.
So we've got an interview next week, and then I've got another one lined up. Potentially, so I'll be doing that.
Yeah, great interview last week, by the way. It was really good. I liked it.
Yep. And because I met somebody on the weekend, met by pure coincidence, and he happened to be it's weird. Like even here in a certain might not be like this in Silicon Valley. It probably happens every day, right? But here in like Australia, right? I went to a friend's farewell, right? He's moving, right? Former Altium guy, by the way. And anyway, so he's moving up the coast. So, I had a farewell, pub thing. So I went there. Turns up, oh, hi, who are you? Oh, I work at, I won't spoil it, but anyway. And it's I've been meaning to contact you guys about getting a tour. It's like, oh, well, let me tell you,
I think when you go to farewell parties, Dave, you are getting what most of us get when we go to meetups, which is serendipity based on actually not that much serendipity. It's just you go hang out with nerds, you're going to find some people that you like talking to.
Exactly. But this is just randomly I've been wanting to contact this company for ages and get a tour. And he said, we'll do a tour. And then it's, So it'll be both a video tour and also we'll do an amp hour as well, because we were discussing that. And it's like, well, I can't, they're really different things. When you interview someone for a podcast like this, it's a different thing to, it's not like I could go shoot my video and then take the audio from that and turn it into a amp hour podcast. It doesn't really work. That
worked in certain situations, like the Shahryar show you did about 5G. No, that was a call. You did another interview with Shahryar that was really good.
I did. That was different. But I did some sit down videos.
Yeah, it was just you sitting there. Yeah.
Yep.
Yeah, I agree.
But we didn't release that one as a podcast, I don't think.
No, we did.
Oh, yeah, we did? Oh, okay.
Yeah, we ripped the audio for that. Okay. But yeah.
But yeah, it usually doesn't. Yeah, they are very different mediums, and you need to approach them differently when you're recording those. For those who want to start their own podcast, which we highly recommend, we don't mind the competition.
We don't. Yeah, bring it on. We have video about it too. We get asked that once in a while. I have a video from 5 years ago now, but it's still kind of valid. So I can link that in too.
A video of how to do podcasting.
It's changed a little bit, but not that much. So yeah,
got it.
Well, we'll look forward to hearing all of your podcasts as well.
All right. Catch you next time.
See ya.